Welcome back to my channel. Today we'll continue with VIP question chapter 10 part 2, questions number 8. The tension of the stretch of the length 80 cm and the mass 2 gram is 190 Newton. Calculate the frequency of the vibrating string if the string is vibrating at the third harmonic. Okay, so when we say third harmonic, meaning that this is the string and this is the first harmonic, second harmonic and third harmonic. So this third harmonic is actually the length is equals to 3 lambda over 2. So we will get the lambda is equals to 2 over 3L, where is equals to 2 over 3. So the length is given 80 cm, so we substitute 0.8. Okay, so we will get, so the answer for the wavelength is 0.53 meter. Okay, next we want to find the frequency. Okay, so we know that F equals to V over lambda, where V is the velocity of the vibrating string. We know that V is equals to square root tension over mu, and mu also equals to mass over length. Okay, so we must find what is the value for mu first, where m is equals to 2 grams, so it's 0.002, and the length is 80 cm, so it's equals to 0.80. Therefore, mu we will get 2.5 times 10 to the power of negative 3. Okay, we substitute into the equations. Tension is 190, mu is 2.5 times 10 to the power of negative 3 square root. Okay, so the velocity that we will get is equals to 190 over 2.5 times 10 to the power of negative 3, and then square root, we will get V is equals to 275.68 meter per second. So we substitute into the equations where V equals to 275.68 and the wavelength is equals to 0.53. Okay, so the answer for frequency is equals to 520 Hertz. So the answer is donkey. Okay, next we go to question number 9. A stretched wire of the length 100 cm vibrates transversely. So the wave travel along the wire is given 230 meter per second. Okay, we found that there is 4 antinodes can be found in a stationary waveform in the between two fixed ends. So find the frequency of the vibrations wire. Okay, so 4 antinodes meaning that if this is the wire, we have 1, 2, 3, 4. Okay, so we have 4 antinodes in this stationary wave. Okay, so meaning that the total length here is equals to 4 lambda over 2, or the wavelength here is equals to 0.5 times the length is equals to 100 cm, or we convert it into meter. Okay, so therefore the wavelength is equals to 0.5 meter. So we want to find the frequency. So the frequency is equals to V over lambda, where V is given 230 and the lambda is 0.5. So the frequency we will get 460 Hertz. So the answer is donkey. Okay, next we go to questions number 10, where questions number 10 here we have the air cooler is placed just below the vibrating wire. Okay, so let's say this is the vibrating wire and this is the air cooler, and the air cooler is below the vibrating wire. So the length of the air coulomb here open at one end is gradually increased until the first positions of the resonance is observed at 36 cm. Okay, so the first resonance here is actually equals to lambda over 4. Okay, so lambda over 4 equals to 36 cm, or we can change it into 0.3 meter. Okay, so where the lambda we will get 4 times 0.36 meter. Okay, and the wire is 150 cm, so the length here is equals to 1.5 meter, and it's vibrating at the third harmonic. Okay, so third harmonic meaning there is 1, 2, 3. Okay, is the third frequency. Okay, so here what the informations we have here is for the string is 1.5 meter is equals to 3 lambda over 2. Okay, so our lambda is equals to 2 over 3 times 1.5. Okay, so because of the word's resonance, meaning that the frequency for the string and the frequency of the air coulomb are the same. So we find air coulomb first. Okay, so for air coulomb, frequency is equal to V over lambda, where air coulomb, the velocity of the sound wave is equal to 330, here is given, and the lambda is equal to 4 times 0.36. Okay, so the frequency that we will get for air coulomb is 229.2 Hertz. And we know that because of the resonance, meaning that the frequency of the air coulomb will equal to the frequency of the wire. Okay, so for the wire, frequency is equal to V over lambda, and we know that the frequency are the same, is 229.2. Okay, and the velocity is the value that we want to find, and the lambda is equal to 2 over 3 times 1.5. So finally, the velocity of the transverse wave in the wire is equal to 229.2 meter per second. Okay, so the answer is A. Okay, questions number 11 here is determine the frequency of the third overtone produced by 34 cm pipe. Is the first one is in the closed pipe. Okay, so for the closed pipe, meaning that one open, one closed. Okay, so third overtone here is equal to, for closed pipe is equal to 7 fundamental frequency. Okay, so we have 1, 2, 3, 4, 5, 6, 7. Okay, so we have the length equals to 7 lambda over 4. Okay, where our lambda is equal to 4 over 7 L, where L is equal to 0.34 meter. Okay, so for the closed pipe, the frequency is equal to V over lambda, where V is equal to 330, and our lambda is equal to 4 over 7 times 0.34. Okay, so our frequency for the closed pipe is equal to 1698.5 Hertz. Okay, next one we will go to the open pipe. For open pipe is actually both open, and for third overtone is actually equal to 4 fundamental frequency. Okay, so it's equal to 1, 2, 3, 4. Okay, so our length here is actually equal to 4 lambda over 2, where our wavelength is equal to 2 over 4 L. Okay, or is equal to 0.5 times 0.34. Okay, so next we want to find the frequency. The frequency is equal to V over lambda, where V is equal to 330 and the lambda is equal to 0.5 times 0.34. So therefore the frequency for open pipe is equal to 1941.1 Hertz. Okay, so the answer here is donkey. Okay, questions number 12. A 3.02 meter air coulomb is open at both ends. The frequency of certain length is 232 Hertz, and the next higher harmonic is equal to 290. Okay, meaning that if you want to find the first harmonic, okay, we can find by using the difference between the frequency. Okay, is 290 minus 232. So we know that the difference between the two adjacent frequency is equal to 58 Hertz. Okay, so 58 Hertz is actually equal to our fundamental frequency, where is equal to V over lambda. So it's equal to 58 equals to V. V is the value that we want to find. And the wavelength for the fundamental is equal to, the length is equal to lambda over 2, where the lambda is equal to 2L. So we substitute into the equations 2L, and the length is equal to 3.02 meter. Okay, so the speed of the sound in the air coulomb is equals to 350.3 meter per second. So the answer is C. Okay, next one we go to questions 13. questions related to the Doppler effect, where a sound source and a person are located at the same horizontal line. The person heard the sound of 520 when the sound is moved towards him. So when the sound is passes him and move away, he hears the sound 450. So determine the speed of the sound source. Okay, so here, okay, f when it is towards the observer, so we can write it as our v over v plus minus our vs times the frequency of the source. So we substitute 330 over 330 because it is approaching. Okay, so approaching, we must put negative v source that we don't know, okay, times the source frequency. Okay, and when it is toward the frequency observer is 520. So this is our first equation. Okay, another equation is f when it is away. Okay, so our v over v, because it's away, so it's plus v source times the frequency from the source. Okay, so f when it's away is equals to 450 equals to 330 over 330 minus v source times the frequency. So this is our second equation. So here we have two unknown. The first one is the speed of the source and the second one is the frequency from the source. Okay, so from equations number 1, our frequency of the source is equals to 520 times 330 minus v source over 330. Second equation, our frequency of the source is equals to 450 times 330 plus v source over 330. So since equations 1 and equations 2 are similar, so we can let equation 1 equals to equations 2, where 520 times 330 minus v source over 330 is actually equals to 450 times 330 plus v source over 330. So 330 and 330 we can cancel off. So therefore 171,600 minus 520 v source is actually equals to 148,500 plus 450 v source. Okay, so 450 plus 520 v source is equals to 171,600 minus 148,500. So therefore our v source is equals to 23.8 meter per second. Okay, so the answer is A. Okay, next questions. The last questions also is a Doppler effect. Okay, where the observer standing at the side of the road, okay, he hears a horn of the car approaching and move away from the observation with a constant speed of 30. Okay, so this is v source. If f1 and f2 are respectively apparent frequency when the car is approaching and also moving away, find the ratio of f2 over f1. Okay, so f1 is actually approaching. Okay, so our equation we can write 330 over 330 because it's approaching, so it's negative 30 times the frequency of the source. Okay, and f2 is actually away, where is equals to 330 over 330 plus 30 times the frequency of the source. So this is equation 1, this is equation 2, where the frequency of the source we can cancel. 330 we can cancel. Okay, so therefore f1 over f2 is equals to 360 over 300. But the question asks us to find f2 over f1. Okay, so it's equals to 300 over 360. So therefore the answer we will get 0.83. Okay, so the answer is B. Okay, so that's all for chapter 10. Okay, thank you. See you on next video. Bye.